So I've just given the sort of intuition I find very helpful for sheaves. I'd like to now talk about Cosheaves. Okay. And I'd like to contrast it to that intuition because it has a very different flavor. Okay. So this is the picture with Cosheaves. You might be excused for thinking, well, it's just dual, so things are just going to be flipped around. And that's true, but it's worth reflecting on what's going on. This picture is exactly the same. This is our familiar post set of opens, right? Now, instead of this being a limit preserving functor from O of X op into set, we have a co-limit preserving functor from this post set of opens into set. So we don't have an op. So this is a co-limit, right? Remember? Do you remember colimits? The idea with colimits, give me an example of a colimit. Many things are colimits. Give me an example. Okay. So you're welcome, and you're giving to give some examples. So colimits of graphs, good. But there are specific types of colimits. Push out is a colimit. Co-product is a colimit. It turns out co-equalizer is a colimit. Turns out you can view epochs as related to colimits, what have you. Initial object. But the ones I want to concentrate on are co-product and push out. The first one you mentioned. Okay. So I'd like you to think about this as kind of a push out like thing. Here, I mean, it's a colimit, right? So it's like we're taking all these things and things that are overlaps, we just treat this the same. That's why it's unioning all of these, right? The union is very much the sense of push out, in the sense that it's just all of U1, all of U2, all of U3, but we're not double counting things that are in both, right? Things that are both, it's just union. If it's in both, there's still only one of it, right? If the element X is in U1 and it's in U2, and gosh, if it's in U3 too, if we consider now the union of all three, there's only one possible X in it. There's only one X, right? So the union is very much kind of glomming, but gluing certain things that are in common, right? So this is what I'm telling you is this is a colimit here. Union is a colimit. And if this is a colimit preserving functor, this maps that over into a colimit. See this colimit here? Okay. Now, just like before, I tried to appeal to the intuition of a pullback for thinking about this for the case of where we had limit preserving functors for sheaves. I want you to think about this as like a push out. And indeed, if we only had this square here and we knocked out all these, this would be a push out, right? The idea here is that this is going to be like a push out, gluing things together, but gluing them together in a way that identifies, sort of treats as the same, the parts that are in common, the parts in the same equivalence class. In this case, it's going to be things coming from the same values from this point here. The values assigned to this point here are going to be in common here. So they're going to be identified together. They're going to be identified together. Now, all these paths commute like before. It's just the paths go in different directions, right? Before they were going down here. Now they're going up, right? So this is kind of going to be like the co-product of, remember I said for sheaves, where this was kind of for sheaves, this was like where the arrows were turned around. This is like the pullback, and it was like a subset of the product of these values, right? Such that all the things restriction maps match. This is going to instead be like the co-product of these, but where we consider as the same values these ones coming from these common points here, these overlapping areas. So here we're going to be getting values from this, and this, but these are not just going to be put next to each other, as John By says, as tinker draw pieces. They're going to be stuck together around these common points. We're going to be fusing them around these common points. We're not going to be double counting for these overlaps. But you may remember that pushouts have this sense of agglomeration, a sense of like sticking things together, gluing them together around these common points, accumulating things, but recognizing some things are in common. And that's very much the sense we're going to have. And what we're going to have is a sense of accumulation here, not restriction like before. With sheaves, we had things as we go up are more and more restricted, more and more. They're pinned down more. They have to be held to the strictures to match multiple things, and they're more and more limited than their possibilities, right? The number of persistent things all through many, many regions is going to be a lot fewer than those that might have persisted through small subregions, right? If it has to persist through all those regions, it's going to be a small subset, right? If it's in a public health intervention that has to be in place in all the subregions, it's going to be a small set that qualify for that, because they could be knocked out if any of the regions disagree, with that value. Here, we're not going to have that set at all. We're going to have all these things from these different regions total up. We're just not going to double count those that are in multiple places. We're not going to double count. So we're going to be able to accumulate things. We're going to be able to accumulate the counts of cases that occurred in these different regions, but recognize that when two regions have common overlap, like they have a certain subregion, maybe we call North Saskatchewan, South Saskatchewan as a whole, and then we have data for Saskatoon in particular, and somehow it's counted in both. North Central and South Central, and Saskatoon is in both, or something like that. In which case, we won't double count the counts from Saskatoon. This will be set of counts for Regina, set of counts for North Central, South Central, and for Saskatoon. And we'll just recognize that when we total it up for the total across those regions, we won't double count Saskatoon. We'll only count it once. That's kind of the flavor. Or if we have public health restrictions in place here for each, we'll accumulate them here, but we won't view those in Regina for work from home and Saskatoon work from home as different. We'll just count it as work from home, because it'll be, it's shared in common there. Okay, so here maybe I'll just so it'll be something like this. So if we have here variant blue and variant red are in Saskatoon, these are variants of COVID-19. Variant green and variant blue are in Regina. Variant light blue and variant red are in PA. If that's what's here, then what we're going to do at this next level is take the variants for Saskatoon and Regina. We'll take the variants in Saskatoon. We'll take the variants in Regina, but we won't double count, like blues in both. So we'll only have one blue, right? We'll take the push out around it, right? If it's in common, remember push out? If it's in common, if it's something which is map 2 from the same value, right? We have blue in common here, blue in common. So we only count it once as blue, right? And so it's like we're taking the union of this set and this set for this. But it's not like we have blue Saskatoon, blue Regina, red Saskatoon, green Regina. No. It's we have blue, we have red, and we have green, regardless of whether they came from. So we accumulate. We accumulate for Saskatoon and PA. We accumulate for Regina and PA. And then similarly, this is an accumulation. So you may remember this for the other case where we were going down. This is what I'm saying. This is like sticking things together, but not double counting. Sticking them together, but gluing around common things. Blue is in common, so we glue around it, and therefore there's just one. Remember what that looked like for sheaves, right? Here we were looking for something that was present in all of these. It had to be present in all its subregions, right? So the one for Saskatoon, Regina had to be present in Saskatoon, and it had to be present Regina, so we have blue and red. And the only one that was present in all of Saskatoon, Regina, and PA was red. But now we are accumulating. We're sticking together, but not double counting. We're sticking together, but gluing. Not just putting these next to each other in a disjoint union as we go up. So that's the flavor, but I want to talk with you more about this wonderful sort of contrasting viewpoint. Okay, so here we go. This is Cosheaves and sheaves. Where's the map? Whence does the mapping come? In other words, from where is the mapping occurring? Here it's for sheaves, it's from opens op, the post set of opens op. Here it's from the post set of opens. Here the functor preserves limits. Here it preserves colimits. Maps. So here preserves limits. So a colimit in opens became a limit in opens op, and it's mapped over to a limit in set. Here, by contrast, we preserve colimits. So a colimit in the opens, which is union, is mapped over to a colimit in set, which is this, well, it's a colimit, so it's this push-out-like thing, right? It sort of glums things together, but glues around common points. The root if over in set is the limit, the root in set is the colimit. Local sections for smaller open sets are for like more like smaller regions or smaller intervals of time. That's what I mean by smaller open sets. They're often larger. They have more possibilities, right? That's what we have for sheaves. Remember that for sheaves, we might have, for example, many particular health interventions, public health measures in place for Saskatoon. We might have many for Regina, but the number in common for both of them in common that were in place for each and every one of those was more restricted. So the smaller it was here, we have larger. Do you remember that? I just showed you that graph, right? We had all these for the empty set, right? And the further up we go, the more restricted we are, right? Right? But contrast for Cosheaves, for smaller open sets, we might have smaller things. The further we go up, we agglomerate, we accrete, but with gluing, right? In both cases, we accumulate and glue together, but we're gaining an understanding of the public health measures in place for any of the subregions, right? Just not counting any twice. If it's only place for one, that's fine. Here, restrictions to sections for intersection lead to compatibility constraints, right? That's what's restricting us, right? That's what's restricting us when we have the this, right? Like we whatever image is here, it has to account for what's here in a way that's compatible with that. That limits the set of possibilities here, limits the set of possibilities here to be consistent, right? The restriction maps need to match, right? That's what's limiting us here. By contrast, the co-restriction maps, what are sometimes called extension maps, they go up from the intersections, right? They go up from the intersections. And they're not about restricting the set of possibilities. They sort of bring elements to be glued together at the upper level, right? They're like they're like injecting things to be considered at the upper level, just not double counted. So here we have restriction maps, here we have extension maps or co-restriction maps. We can think of this as on the left, for some of our cases, not all, but it's filtering to find the persistent ones, the ones that are in place for each and every interval or each and every subregion. We're finding here, it's like we're finding things in any interval, any subinterval that's there. We're accumulating just with gluing to not double count. Okay. So here we are sort of characterizing data that as we go up is successfully filtered by constraints and different areas of the space to be more and more pinned down, more and more specific, more and more restricted in its possibilities, more and more particular to the case. Whereas here we glue things alongside each other but identify them. The analog here is kind of how pullbacks are a subset, a restricted form of products, right? We're finding the compatible combinations, right? Not just all shirts, all pants, all combinations, but that'll be product. Pullback is shirts and pants of the same color. It's a restricted subset of that. Here, we instead have our points of reference be co-products, which for set, what is co-product for set? Anyone remember? Yeah, disjoint union. Disjoint union. Do you remember that? The example I had was like Alice's pair and Bob's pair. And if Alice had a pair and Bob had a pair, we'd count them different. The thing that made push out is we'd recognize, oh, that's both a pair. So we'll just count one pair. We won't worry, or that's what a push out is, right? Here, it's very much a push outy sort of situation. It's we are glomming up, but identifying things, gluing things together. We're agglomerating, but gluing common things, identifying common things. We are accumulating, but gluing around duplicate elements. So that's the picture with Cosheaves. This was you remember our push out here. We had this, and if we didn't have C, if we ignored these, or if C is empty set, right? Which comes to the same thing. These don't add any information. Then this is just what. So if we leave these out, what is this? This is what is the push out when C is empty, or if we just leave this out altogether, we get, what does this look like? The coproduct. These are injection maps. Sure. This is Alice's stuff, and Alice's apple goes in and gets there, and Bob's apple goes there. I guess B should be Bob, H should be Alice. Okay. But if C is not empty, then now we're taking A's and B's, but we're identifying some as the same, right? We're identifying some is in common. We're taking A's and B's, but treating those that are mapped to from the same C as in common. Hmm? Mm. So you remember that. And the push out is kind of the best one, right? We glue A and B together, taking the image of C and each in common, treating it as the same, right? Okay. Okay, so you remember with sheaves, this is this variant idea with sheaves, the local section as its elements a set. This would be for sheaves. The local section for open set V, local section F of V has as elements a set containing the COVID-19 variants detected in every municipality within region V. It is the sense of requiring it for everyone. They have to agree on this. They have to agree, because whatever one we want to have at a given level, it has to be in multiple places where, for the overlaps below, et cetera. It has to be in every municipality. The restriction map here basically finds variance for each municipality of this to the set of variants in this. So it has to find whatever's here, whatever elements are here, the set that are here. It has to be able to be here in this case. It's just a one-to-one mapping, right? There's no translation going in this particular case. It's a kind of just finding this in this. And the equivalence with restriction maps require that they map down to shared elements. And a given global section is consistent reporting of, this is again for sheaves, for variance consistently reported across all municipalities. But for Cosheaves, this is, instead of local section being a set which has variance detected in every municipality, each and every one, no. Now, for Cosheaves, the local section is a set that reports elements that are detected in any of the municipalities. Mm-hmm. Again, glomming up, taking all of these things, just not double counting. The extension map it relates basically those that are here and basically injects them to be into that set that are up here, just like with the push out, this kind of injects here, but just doesn't double count anything mapped to from the same C. It's the same idea here. It puts it there, but it doesn't double count. If it came from I and it came from J, it only counts once. Yeah. So the quotienting with respect to the extension maps, in fact, it's kind of a push-outy thing, means that if it comes from F of UI and F of UJ, we only count it once, right? We count as the same, or glue it around it. And a global section is consistent reporting the variance reported across any municipality. Mm-hmm. So these are our Cosheaves. Okay. Now, yeah, so those are flavors of